Hello everyone, this is the first lesson recording for IM1, February 26, 2021. We started by considering this scenario. Okay, we have a zombie apocalypse. Oh no! On day 0, a Zoom zombie has escaped from Area 51 and is infesting our online school through Zoom bombing. And each day any zombie, or maybe you can call it zombie, infects 2 humans who turns into infectious zombies at the strike of midnight. So the question is, how many zombies are there after day 3 and how many are there after day 4? I would like you to pause the video and see if you can figure out how many you would have in day 3 and how many on day 4. Okay, so what are we doing today? We are going to be exploring new exponential growth situation and also working with percentages. So let's get back to our Zoom zombie problem. Okay, let's talk about our 4th period, since that is my first of the IM1 period. Remember, we were told that we are studying with 1 zombie on the first day. So let's pick a student to be our very first zombie who escaped from Area 51. Okay, let's see. Who are we going to choose? Let's choose Carlos, since he is in the middle. Okay, so we're going to say that he is our Zoom zombie. Sorry, Carlos. So I'm going to say you are a zombie. So on day 0, we have 1 zombie. Okay, and at the strike of midnight, so on day 1, in the beginning of day 1, he's going to infect 2 other zombies. Okay, on day 1 he's going to infect 2 other zombies. So then on day 1 he's going to infect 2 others. So let's put, okay, who's near? Marco and Dawn are zombies by day 1. And so how many zombies do we have in day 1? We have 3. Okay, now we have 3 zombies in day 1. What happens in day 2? Okay, we have 3 zombies, but each of them are going to be infecting 2 more. Okay, so Marco is maybe going to infect Evelyn and Kailoni, and maybe Carlos is going to be infecting Anya and Adrian. And maybe Dawn is going to be infecting Stephanie and, let's say, Cesar. Okay, so how many zombies do we have by day 2? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 zombies by day 2. What about day 3? We have 9 zombies on day 2, and each of them are infecting 2 more. So for example, Evelyn is infecting Blake and Giovanni. Anya is going to be infecting, let's say, Ethan and Michael. Adrian is infecting 2 and Moses. And Dawn is infecting Edgar and, let's say, Anady. Carlos is going to infect 2 more, so Jonathan and Diana. And Marco is going to be infecting Iris and Kiana. And Kailoni is going to be infecting Christian and Diana. Okay, so they are the new infections, and Stephanie and Cesar were also infected previously, so Stephanie is going to be infecting 2 more. And Cesar is going to be infecting 2 more. In fact, there will be even more than what we have in our class. So how many do we have? In fact, everybody is infected by the next day. And so that is 1, 2, 3, 4, 5, 6, 7. 7 times. So we have 27 students being infected on day 3. Okay, do you see a pattern here? 1 became 3, 3 became 9, 9 became 27. Do we need to go through that anymore? Okay, on day 4, what do you think? day 4, we are seeing that the pattern of being multiplied by 3. So I am going to say 27 multiplied by 3 is going to be 81. So my prediction for day 4 is we're going to have 81 Zoom zombies walking around on our school campus. Okay, that's not a great news. Okay, but look at how quickly the numbers grow. That's the power of exponential functions. When it takes off, it might take very long time to take off, but once it takes off really, really fast. Okay, something else. Are you a little bit surprised by the fact that we're multiplying by 3? Wouldn't you be thinking that, oh, but each day, when each zombie is infecting 2 others, so my thinking is maybe I'm just going to multiply by 2. Why is it 3? Well, think about that. That's because you have yourself and 2 more. So we are creating 3 more zombies each day. Or 2 more zombies that includes yourself, 3 zombies each day. So you're creating a 3 times number each day. So let's see if we can figure out the rule. Okay, so this is the table that we had. So on day 0, we had 1 zombie. On day 1, 3, 2, 9 zombies. On day 3, 27 zombies. On day 4, 81 zombies. So if I continue this pattern, what do you think? How are the numbers related? Okay, how are the numbers related? That's what we're looking for. Well, I can rewrite these numbers 1, 3, 9, and 27 and 81 as 1 is just 1, okay? But I am multiplying by 3. From 1 to 3, I am multiplying by 3. From 3 to 9, whatever the number was, which was 3, I multiplied by another 3. From 9 to 27, I multiplied whatever the number it was, which was 3 times 3, by yet another 3. So do you see the pattern on the 81? 81 can be rewritten as 3 times 3 times 3 times 3. So whatever the previous number was, we just multiplied by another 3. So here, the previous number was 1, we multiply by 3. Here, to go from here to there, the previous number was 3, and then we multiply by another 3. So you got 3 times 3. To go to here, the previous number was 3 times 3. 3 times 3, that's from the previous, and then we multiply by yet another 3. And then 3 times 3 times 3 represent the previous number, and then we multiply by additional 3. So what do you think will be the rule? Well, if we're talking about day 0, we're talking about a variable, then we will be talking about, look, 3 is being multiplied 4 times here, 3 is being multiplied 3 times here, 3 is being multiplied 2 times here. Okay? So in this case, 3 will be multiplied to itself x number of days when we're talking about day x. So the equation becomes, or the rule becomes, the number of zombies. If we say x is my number of zombies, which is my y, number of zombie is y, and number of day is x. And this is y as well. Okay, so y is going to be 3 times x. So that's going to be my equation that represents this situation. Okay, let's extend that situation. What if we started off with 2 zombies that escaped on day 0? How many zombies would you have on day 3? So instead of 1 zombie escaping, we started off with 2. So that means the table will look like this. So on day 0, we had 2 zombies. Assuming that we are still following the same rule that each zombie infects 2 more each day, that means we have 2, and we are going to multiply that by 3 because each zombie is creating 2 more and plus himself. So each zombie goes from 2 to 6, and then 6 to 18, 18 to 54, 54 to 164. And if I create another column that breaks down, how we created these numbers is that 2 is just really 2 times 1, and then whatever the previous value was, which was 2, I multiply by 3. Whatever the previous value was, which is 2 times 3, I multiply by yet another 3 for the next day, and the previous number was multiplied by another 3, and the previous number was multiplied by another 3. So what do you think is the rule for this? If for day 0, day X, it looks like on the day 4, we multiplied 3 to itself 4 times, and then we multiplied by 2. On day 3, we multiplied 3 to itself 3 times, and then we also multiplied 2 to it, and so on. So in this case, I can see that this part is going to be 3 to the power of 4x. Then to that you're going to be multiplying 2. So that becomes 2 multiplied by 3 to the power of x. Okay, let's just extend that even further. What if we started with 5 zombies on day 0? What is the equation? Well, let's start with the table. Okay, on day 0, I would have had 5 zombies. Each of them is going to infect 2 more. And so at the end of that day, it has itself and 2 new zombies. So that means 3 altogether. So I'm going to multiply 5 by 3, so 15. And then 15 by 3 is 45. 45 by 3 is 135. And 135 by 3 is actually not 162. That's a typo. Okay, so that is going to be what? Some other number. Okay, but let's look at the pattern here. Okay, so again, the first line is 5 times 0, or 5 times 1, I'm sorry. And then whatever the number was, I multiply by 3. And then whatever the previous number was, I multiply by another 3 to get to the next number. And that number was multiplied by another 3 and another 3. And again, looking at the pattern here, 3 is being multiplied 4 times and to itself 4 times and then multiplied by 5. So in this case, I can say that for days X, I can generalize the pattern as 5 times 3 to the power of x. So what does this tell us? Okay, what does this tell us? Remember, previously we just said that if the 2 zombies escaped, if we started with 2 zombies, we got equation to look like y is equal to 2 times 3 to the power of x. And we just said that if you had 5 zombies that escaped, we would have the expression that looks like 5 times 3 to the power of x. And the very original question was 1 zombie that escaped, and we had the expression y is equal to 3 to the power of x. Okay, so what do you notice? The pattern is still the same. 3 to the power of x, 3 to the power of x, 3 to the power of x. That is still going to be the same because the rule about each zombie infecting 2 new zombies each day did not change. However, the initial value changed, and that 5 and 2 represents the initial value on day 0, or the number of zombies on day 0. So that's the pattern that we are observing.